All right, so using Venn diagrams, I'm going to show that A intersection B union C is the same thing as A intersection B union A intersection C. I do want to point out that a lot of times statisticians won't write the intersection sign. So this is exactly the same thing as if you wrote this without the intersection. Okay, so when you see two events that are written next to each other, that means that you are intersecting them. Okay, does not mean that you are multiplying them. If they were variables, you would be multiplying them by each other. But since they are events, you are going to be intersecting them. Okay, so let's start with A intersection B union C. So I'm going to draw my Venn diagram. All right, so I have A, B, and C inside of a sample space. Okay, so this is A, B, and C. All right, so you always want to start with inside of our parentheses. All right, so where is B union C? All right, so what does union mean? Union is either or, right? So that means I must belong, or an element must belong to either B, or the element can belong to C. All right? So this is where B union C is. Okay? Now if you're trying to show something using Venn diagrams, a lot of times it's helpful to draw this out using multiple steps. Okay, just kind of how like when you're solving a math problem, you might have multiple lines of that problem. Same thing goes when you have Venn diagrams and you're trying to show something. All right, so A, B, and C are still here. And now I'm looking for where these guys intersect. So I'm going to use, let's say I'll use purple. So I'm looking for this intersection between A, B, union C. Okay, so where they intersect. In other words, I'm looking for where A and the green part is. Because remember, intersection means and. So that would be right here, right? So that would be right here. Okay, this is where they intersect. That means where you're part of A and you're part of this green area. Okay, so this purple area is where A, B, U, C is. Basically, it is this purple area is where the left-hand side of this equation is. All right, so now let's go over to the right-hand side of the equation. I have my Venn diagram. Let me draw that a little better. Okay, so I have A, B, and C. A, B, and C. Okay, this first part here is A intersection B. Where does A intersection B happen? I'll use blue for that. So A intersection B, remember that would be where A and B are. Okay, so that would be right here. Okay, so this is A intersection B. Okay, what I've marked here in blue. All right, so then let's draw another Venn diagram and let's look for A intersection C. So here's A, B, and C, and I'll use again a different color. So I'm looking for A and C. So here's A, here's C, so that would be right here, where both A and C are. Okay, and then lastly, when you take the union of this blue area and this green area, what do you get? So union means either or, right? Oops, let me undo that. Okay, so now I'm going to take the union of these. Just realized I forgot to write A, C. So I have A, B, and then AC. Okay, A, B, and C are here. Okay, so I'm looking at this being in this AB area. Okay, AB area, or in this AC area. Okay, that would be where AB intersects with AC. All right, now let's see if we have this relationship, and we see that they are identical. Where I've shaded in is exactly the same. So we have successfully shown using Venn diagrams that A intersect B, or A intersect B union C is the same thing as A intersect B union A intersect C.